Good morning, Lillian. I'm one of your fans. Please help me calculate how many hours a 17.5 kilowatt hour battery will last on one freezer, one fridge, two ceiling fan, 40-watt bulbs. All right, if you're watching this as that fan, please pay attention, and any other person that will have similar question, so that we trash everything together here. Is that okay? So let's go there. So we have one freezer, one fridge, ceiling fan, two ceiling fan, and 40-watt bulb. Please, for the purpose of this video, I'm going to use this load. Endeavor to check the back of your appliances to ascertain the actual load of your appliances. Is that correct? So for the purpose of this video, I'll be using 150 watts for the freezer, 120 watts for the fridge, ceiling fan 70 watts each. So it's going to give me 140 watts, right? And a 40-watt bulb. Perhaps maybe the bulbs are 4 or 10 depending on the wattage of each bulbs. So together we'll have 150 plus 120 plus 140 plus 40. What do we have there? We have 450 watts. That is the total load. This is the first thing you do after your load audit in a house. You do your what they call your load calculation. This is the first step you take by calculating the total loads of the appliances that you are working on or you want to power. Let's go there. Then remember, we want to find out how many hours a 17.5 kilowatt hour battery lasts on this particular load, right? So this is 17.5 kilowatt hour. Now this is wattage. So is either I convert this wattage to kilowatt, so it reads the same thing, or I convert this kilowatt hour to watt hour so that they can have the same unit. So what do? I think the easier thing to do is to convert to watt hour. So to convert to watt hour, I will simply multiply by what? 1000, right? So I'm going to have 7500 watts. Is that correct? Watt hour. Now remember, our formula that we're going to use is what? Time is equals to energy, right, divided by the load, the total loads of the house. Energy is measured in watt hour, while load is measured in watts, right? So that watt cancels watt, you have your hours, which is your time, right? But we are not going to use the nominal capacity of the lithium battery. We are going to use the usable capacity. And for us to use the usable capacity, we are going to multiply the nominal capacity by the DOD. That is the depth of discharge of the lithium battery. And the depth of discharge of the lithium battery is 0.9 for a good lithium battery. So I'll multiply this by what? 0.9. So if I multiply this by 0.9, tell me the answer. What do I have? 15,750 watt hour, right? So I will just simply divide. This is the energy, which is the 15,750 watt hour, right, divided by the load. And what is the load that we got? We got 450 watts, right? So this wattage cancels this wattage, right? So we divide this over this. What do we have? Answer, so that we'll do it together. Then we have what? 35 hours. You find out that a 17.5 kilowatt hour lithium battery will carry the total loads of this house for 35 hours. That is for 24 hours and some hours again. So this is how you apply it if you are using 15 kilowatt hour, 20 kilowatt hour, 10 kilowatt hour, 2.5 kilowatt hour on your load, so that you ascertain the actual hours these loads will last. Do not also forget power losses and other factors, but this is how it's going to last. So I believe you have been the fan that asked me this question. You have got your answer, and every other person, you have got your answer on this. Thank you. Don't forget to contact us to design a proper solar solution for you. Solar installation anywhere you are in Nigeria will come at your doorstep. We are just one call away and we'll be at your doorstep. Thank you for always watching and following. I love you. I'm rooting for you. See you next time.